Hello, children. Today we will begin with a new chapter in geography, that is, properties of sea water. Oceans are the largest water storage of the world, and you know that sea water is always salty, which they get from rocks on land. Even rivers carry dissolved salts to the ocean. Water evaporates from the oceans to feed the rivers, but the salts remain in the ocean. Temperature also plays an important role in the oceans. There is a difference in the temperature of land and sea. During the daytime, land is hotter than the sea, whereas during the night time, land is cooler than the sea. So, children, in this chapter, we are going to learn the three main properties of seawater, that is, salinity, temperature, and density. Salinity is the amount of salt in the seawater, and different temperatures across the globe that affects the oceans, and the density, which is the weight or the mass of the seawater depending on the percentage of temperature and salinity present in it. Now, children, temperature is a major property of the seawater. The surface temperature of the seawater is not uniform everywhere. This is dependent on different factors. So, children, you know that our globe is spherical in shape and different regions get different type of sun rays. So that is why the temperature varies or differs from one place to another. Now, latitudinally speaking, those are the imaginary lines on our globe. So, according to the latitudes, the surface temperature of the sea water decreases from the equatorial areas towards the poles. The average temperature in equatorial areas is around 25 degrees Celsius. It is 16 degrees Celsius in mid latitudes, while it is about 2 degrees Celsius near the poles. So, children, you can see that in the picture that the middle part, that is the equator, okay, there the temperature is the highest, okay. So as you go away from the equator, that is a temperate zone, it becomes little bit warmer, okay. So the red one shows you that the temperature there is very high, it is very hot. As you go towards the temperate zone, there it is little bit warmer, not hot. And then towards the polar regions, it is cold. As you all know, the North Pole and the South Pole is the cold regions. That is why the temperatures fall down to very below. Besides this, okay, besides all the zones that we have, the temperate, tropical, polar regions, there are other things that affect the temperature, like cyclones, rainfall, sea waves, ocean currents, salinity, that is the amount of salt present in the sea, then even pollution, convectional currents, okay, that we have learned in 8th standard, the different type of ocean currents, then even seasons, okay, different seasons, rainfall, winter, also affect the surface temperature of the oceans. Ocean currents also have similar effect on temperature of the sea water. You all know, right? The warm ocean current and the cold ocean currents. They also affect the temperature of the sea water. In regions where cold ocean currents flow, okay, you can see that in the picture. So near the regions that are near the polar regions, we have cold ocean currents. So when they flow, that place, the surface temperature of the ocean water is less. Why? Because they are consisting of cold currents. While the regions where the warm currents move, okay, the temperature increases because the currents are warm. Now children, in front of you, you can see a graph. Okay, so in this graph, it is showing the depth and temperature of sea water. Now, towards your left hand side, okay, this side if you see, you can see the depth, that is the the deepness of the ocean from 0 to 2000, and on top you can see the temperature, that is 0 degree, 5 degree, 10 degree, 15 degree, and this dotted line is the torrid zone. Torrid zone is the equatorial zone. Okay. This blue line that is shown is the mid latitudes. And this pink line that is shown is the high latitudes. Now let's understand this graph by looking at it. Now children, while most of the sun rays, okay, the sun rays that come from the sun, they radiate back from the surface of the sea. Radiate means what? They are, they go away. As they hit the water, they are taken back from the water as soon as possible. It cools down. But some of them get penetrates into the depth of the water. Means some of the heat that the water gets from the sun is absorbed by the water into the depths of the water. Okay, that is the sea water. Now, as a result, the intensity of sun rays decreases. That means as the depth becomes higher and higher, like in the surface, the temperature is high because it is directly hitting the surface of the water. But as you go deeper and deeper, okay, as you go deeper here from 1000, 1500, 2000, in these depths the temperature is lowest. Okay, why? Because the sun rays cannot reach till those kind of depths. So temperature decreases, okay, up to 2000 meter depth. You can see the last one. After 2000 meter, okay, after 2000 meter, the temperature of the sea water is uniform. Okay, so wherever you go into the oceans, after this depth, that is 2000, the temperature will be uniform. So what is the temperature? The uniform temperature everywhere after 2000 is 4 degree Celsius. Okay, everywhere from the equatorial regions to the polar regions. So after 2000, okay, the temperature goes down to 4 degree. Okay, that is this side. Okay, before the pink line. Now the temperature reduces only up to 4 degrees Celsius according to the depth, and therefore the water at greater depths does not freeze. That means even in the deepest part of the ocean, the temperature is 4 degree. Okay, it is 4 degree. It does not go below that even in the polar regions. Why? If it goes below 4 degree, okay, like 2 or 1, then whatever animals, aquatic animals and plants are there, they will freeze. So that is why the temperature below 2000 meter or depth is 4 degrees Celsius and not less than that. The temperature of the seawater changes rapidly with depth at the equatorial areas. So if you see that torrid zone, okay, it is continuously changing rapidly with the depth of equatorial areas. So the difference in temperature is lesser in polar areas. There is also a difference in open seas and landlocked seas. You can see that in the picture I have given you. That is a landlocked sea. What is a landlocked sea? It is a kind of water body that is surrounded by land, okay, in all the four sides, and it does not get any kind of fresh water. So as the salinity of landlocked sea is more, okay, because there is continuous evaporation and no fresh water is added to the landlocked sea. That is why the salinity, the salt content in the landlocked sea is higher. The temperature of these landlocked seas is higher. Okay, it is higher than the open seas. Why? Because the water is, there in one place only. Even though it is getting evaporated, it is not moving. Okay, so that is why the temperature of these landlocked sea is higher than the open seas. This is true for low latitudinal areas. That is, wherever there is low latitudinal areas, this is true for the temperature to be higher at the landlocked sea. Now children, there are a few questions that are asked, okay, by looking at this graph. So the first question is, what is the maximum temperature of seawater in equatorial areas? How much is this temperature at a depth of 500 meter? So let's answer to the first question. That is maximum temperature of seawater in the equatorial regions. So now if you look at this line, okay, the dot line is the equatorial region, that is a torrid zone. So now here the maximum temperature of the seawater in this area is 18 degrees Celsius. You can see, right, the line that is just before 20. Okay, so that is why the temperature here is 18 degrees Celsius. Now, how much is this temperature at the depth of 500? Now, same thing we have to see, okay, at 500, okay, this is 500. Now, at this depth, how much is the temperature at 500? So, at 500, we can see it is, how much children? It is 11 degree Celsius. You can see this, right? It is 11 degree, okay, at 500. It is around 11 degree Celsius. Next question. What is the temperature of seawater at the sea level in the mid latitudes? Now, you can see the mid latitudes with the blue color. So, what is the temperature? Okay, so the temperature of seawater at the sea level in the mid latitudes is around 14 degree Celsius. So you can see the mid latitudes here, right? Okay, so at the sea level, the temperature is around 14 degree. You can see this, right? This is the sea level. Okay, so this is the sea level. So near the sea level, the temperature is before 15. So how much it is, children? It is 14 degree Celsius. Next question. How much has this temperature changed at 1500 meter depth? Now this same temperature, okay, same, that is the mid latitudes, how much it has changed at 1500 depth? So the temperature is about 5 degrees Celsius at the depth of 1500 meter depth. So if you see here, okay, near 1500, the temperature is about 5 degree. You can see that, right? Here we have 5 degree. So if you take a scale and see how much is the degree or temperature. So at 500 deepness or depth, it is 5, that is 1500 depth, it is 5 degree Celsius. So thus the temperature of seawater at mid latitudes has changed. Okay, so earlier it was 14, right? Okay, at sea level it was 14, but at the depth of 1500 it became how much, children? 5 degree. So it has become less from 14 degree to 5 degree. So it has reduced by 9 degrees. Okay, so why this has happened, children? Because the depth has increased. Okay, this is deep down into the ocean, 1500. That is why the temperature has decreased to 5 degree. But at the surface it was how much, children? 14 degree Celsius. Next question. What does the thermal graph for the high latitude say? What is its temperature at 500, 1000 and 1500 meter depths? So children, in high latitudes, okay, that is a pink line that you can see is a straight line. So the high latitudes, the temperature of seawater at all the depths, that is 500, 1000 and 1500 is same. You can see that the line is straight, whereas the blue and the dotted line is curvy, but this line is straight. So that means that at high latitudes the temperature is constant. Okay, it is constant at how many degrees, children? It is constant at 4 degrees. You all can see it here. Okay, it is here just before 5 degrees Celsius. So the temperature at high latitudes is 4 degree Celsius. Next question. After what depth does the sea water temperature remain stable everywhere? So I have told you earlier also that the temperature becomes stable after 2000. Okay, after 2000 depth. Okay, that is 2000 meter. The temperature of the sea water is uniform. Okay, that is how much, children? It is 4 degree after 2000. Okay, after this 2000 it is constant. Okay, the temperature does not change after this depth. Now children, as you all know that seawater is salty, and the reason for high salinity in the ocean is because of the high rate of evaporation and low supply of fresh water. And children, do you know how to obtain salt from the ocean water? So, we can obtain salt from the sea water or the ocean water from salt pans. You might have heard about it, right? So, the sea water is collected in shallow pits, okay, or salt pans, and the water is allowed, okay, in the salt pans the water is collected. Okay, so this water that is collected is allowed to evaporate in the sunshine, open sunshine. So in a few days the water evaporates, okay, leaving the salt behind. The water gets evaporated and the salt is left behind. The salt that is obtained is collected and transported to factories where it is purified and packed for consumption. Now children, do you know what is the use of these salts for us in our day-to-day life? Now children, salt is used in the food we eat. Salt is also used for making various chemicals and medicines. It is also used to preserve things for longer periods, like pickles. You might be knowing about it, right? It is also used in ice factories. So children, if you remember our last lesson that we did, that is the experiment that we did for rainfall, okay, for artificial rainfall, on the lid of the container, what did we put? We put ice and salt, okay. So salt is also used for that purpose as well. So salt is used for various purposes. Now, the buoyancy. What is the meaning of buoyancy? Buoyancy means the ability to float in water. Okay, how the ships and all they float on the water, right? So, the buoyancy of the seawater increases because of salinity. So, the more the salt content in the seawater, the that much we get the ability to float any kind of objects to float in the sea water. This is useful for water transport. As I told you all, ships and all, they travel, they are able to transport because of the density of the water, that is the sea water. But children, if this salinity is more, okay, extremely more than bearable, then what will happen? The life that is there in the sea or in the oceans, all the aquatic animals and plants will be destroyed. That is why more salinity is also not good. It should be equal. Now, here we have an activity. For this, we need to take 1.5 liters of water in a big container and then put 100 gram of salt in it and stir continuously until the salt is dissolved. After that, you need to take 3 containers or bowls of the same size. You can see that in picture number 2. Now, because the containers are similar, okay, same containers, so when you want to identify them, so in order to identify them, make 3 dots or make some markings using, sketch pen, markers, so that you can identify them with different colors. Now, put the water containing salt equally in the 3 containers. Okay, that the salt water that we prepared has to be poured into these 3 containers equally. Make sure the containers are half empty. That means when you're pouring the water in the container, it should be seen that the bowls or the containers are half empty. Next, taste the water. Now, after you have put the water into the containers, we need to taste the water to see how much salt is present in the water. Now, after tasting the water from the containers, you need to keep one of the containers, okay, one of the container into direct sunlight, okay, outside. Okay, that is the 4th picture. You need to keep the bowl or the container into direct sunlight. Now, after placing it there, we need to cover it with meshed lid. Meshed lid is a net, a net type cloth. You need to cover it with the net. Now, after that, keep the remaining 2. We had 3, right? 1 you kept outside in the open sunlight. The 2 remaining ones, keep it in a room, okay, in a closed room. It should not be, open towards the sunlight. It should be inside in a room. And cover those 2 bowls or containers also with net lids, okay. Then put half a glass of fresh water daily in one of the containers in the classroom or in the room where you have kept it inside. So, the 2 containers that you have kept in a room or a classroom, in one of them you need to put fresh water daily. So by this you understand that this activity is not of one day. It has to be continued for 3 to 4 days. So continuously for 3 to 4 days you need to pour fresh water in one of the bowls. After that, so after 3 to 4 days, okay, of doing this activity, you need to bring all the containers together in one place and observe, okay, observe the level of water, okay. You need to see after 3 to 4 days what is the level of water in all the 3 containers, and you need to also taste the water to see in which container there is more salt, okay, which container is more salty or there is more salinity. Now children, after doing this activity, in which container you think has the water increased or decreased? So children, the water might have increased in the container in which, okay, which was kept in a room and continuously for 2 to 3 days or 4 days, water, fresh water was added to it. Whereas the water has decreased in the container which was kept in the sun outside. Okay. Now, what could be the reason behind the decrease or increase? Why it might have increased or decreased? So children, since fresh water was added to the bowl that was kept inside the room, okay, that is why the water level has increased, okay, because fresh water was added daily. And in the other container that was outside in the sun, the water in it has decreased. Why children? Because it was directly kept in under sunlight. So when you have kept water under sunlight, what will happen? There will be evaporation. And because of evaporation, the water will be decreased. What could be the reason behind the low and high salinity of the water in the container? Now, in the container which is kept outside in the sun, due to high rate of evaporation, the salinity is high. As we kept on adding, okay, in the second bowl, the water, the salinity was less, okay, in which we kept on adding water. So why did the salinity become less in that? Because more and more fresh water was added to that bowl. So that is why the saltiness of that water became less. So now children, after doing this activity, you will realize that because of the sun's heat, evaporation happens at a faster rate. That is why, right, whenever we dry the clothes outside, the clothes, dry out quickly. Why? Because of the process of evaporation. The same thing happened with the bowl that was kept outside in the sunlight. Now, evaporated water turns into water vapor and reduces in quantity. It becomes less. But amount of salt remains the same because when evaporation takes place, only water goes away, not the salt. So, in the remaining water, and therefore the salinity of the water increases. So, similarly, in seas, okay, in reality, in the real world, in seas where the rate of evaporation is high, then the supply of fresh water salinity is high, like in the oceans or in the seas where rivers do not bring in water, okay. So there what happens, evaporation is very, happening every day, but there is no fresh water coming into the oceans or the seas. That is why the salinity is high in that place. In seas where the supply of fresh water exceeds, that means there are many rivers that are giving fresh water to that particular sea, then what happens? There is evaporation is there, but at the same time fresh water is also added to it. So that is why what happens? The salinity is low, as it was in the bowl that was kept inside the room and fresh water was continuously added. Now, salinity is not affected. Okay, salinity is not affected much in seas where both the supply of fresh water and evaporation of water is low. Okay. Now children, do you know how is the salinity of the sea water measured? So, the weight of all dissolved salts, okay, you all know, right? The salt is dissolved into the water in our oceans and seas. So, the weight of this dissolved salt in water in ratio of parts per thousand of water is called the salinity of seawater. That means the salt that is dissolved in the ocean or the water, okay, it is being measured according to the parts per thousand. So for example, if the weight of dissolved salt, okay, suppose there is salt that is dissolved in a water, so the weight of that dissolved salt is 1000 gram, okay, just for example, that is 1 kg of seawater, so that becomes 40 gram. Then the salinity is 40 parts per thousand. So salinity is being being read as 40 parts per thousand. That is how it is being measured. Now, mostly salinity of water is measured using different equipments like hydrometer. You can see that in the picture. Then also a refractometer is used and salinometer. These are the three equipments through which you can measure salinity or the dissolved salts in the seawater or any water. Now children, in front of you we have the world map, okay, which is showing the salinity of sea water, okay, across the different type of oceans. Now there are a few questions that are asked which we need to answer looking at the map. Now children, first question is, what is the salinity around the tropics? Now children, what are the tropics? Tropics are the regions that are, just beside, that is this area, okay, this middle part, okay, beside the equator are called as the tropics, okay. So what is the salinity according to the map around the tropics? So the highest salinity around here is around 36 part per thousand. You can see, right? The highest one is here. Okay, rest of them are all around 35. Okay, 35. So here you can see the salinity around the tropic. Okay, this is a tropic, that is the equator. Okay, so here it is around 36 part per thousand. Second question, which region has the least salinity? Okay, low salinity, which region has? So after looking at this map, we can see that Bay of Bengal in India, okay, just near here you can see it is 32 parts per thousand. It is not visible, but you can see that in your textbooks. It is around 32 near the Bay of Bengal near India. Next question, which ocean has salinity more than 37 part per thousand? Now we need to see which ocean has this much of salinity. Now when you come near the Atlantic Ocean, okay, this is the Atlantic Ocean. So here you can see we have 37 part per thousand. Here you can see the Atlantic Ocean is having 37 part per thousand salinity. Next question. What are the reasons of differences in salinity in a global level? So children, what may be the reasons for different type of salinity in different part of the oceans? You can see 36, you can see somewhere 35, somewhere 34, 32. What is the reason behind the differences in salinity? So the reason is the uneven distribution of temperature. Okay, there is different type of temperature in different part of the world. Okay, and even the uneven supply of fresh water, because somewhere the oceans get more fresh water, somewhere they do not get at all, somewhere there is little. So these are the reasons of differences in salinity on the global level. Now children, the uneven distribution, okay, that we just talked about, of temperature on the earth is mostly because of the uneven supply of fresh water, right? And it affects the salinity of sea water. Okay, in tropical zone temperature is higher. Okay, tropical zone, if you look at this map, you can see the tropical zone. Okay, that is in oranges or yellowish. Okay, that is the tropical zone. So in the tropical zones the temperature is high. Why? Because it is near the equator, and the rate of evaporation is also higher. Okay, so the more the heat, the more the evaporation takes place. Therefore salinity is higher around 5 degree north and south of the equator. In the equatorial calm belt, the sky is cloudy for a long period of time. Okay, and convectional rainfall, okay, that we learnt in precipitation. So you all know that near the equatorial areas convectional rainfall takes place. So this area that is there is mostly very cloudy. In the afternoons there is convectional rainfall that takes place every day in the afternoons. So large rivers like Congo and Amazon in the equatorial regions meet the sea. Okay, that is the fresh water. Rivers are the fresh waters. So these rivers, that is Congo and the Amazon river, they meet the sea. Therefore the supply of fresh water is lot. Okay, too much of water is being supplied into the oceans. But because of high temperatures, okay, the rate of evaporation is more, and therefore the seas in these areas are more saline. So children, what is happening is that even though there are two major rivers like Congo and Amazon river, they are giving out their fresh water into the oceans of the tropical regions, but yet the salinity is more. Why? Because these regions are very hot. So because of the heat there is more evaporation that takes place. In the mid latitudinal zones, okay, so mid latitudinals are beside the tropics. So before this we talked about tropical zone, right, which is very hot. Now mid latitudes are the zones which are beside the equator. Okay, the green ones, if you can see, are the mid latitudes. Okay, here the green ones. Okay, so these zones, that is around 25 degree to 35 degree north and south, rainfall is less in these regions. Okay, and the supply of fresh water from rivers is also low. So that means there is no fresh water in this region. So this zone has many of the hot deserts of the world. You can see in the next picture here, like the deserts like Sahara, Arabian Sea, the Indian Thar Desert in Rajasthan, the Syrian Desert, the Kalamari Desert, the Atacama Desert. So these are all the largest deserts of the world. So all these biggest deserts of the world lie in the mid-latitudinal regions. So, thus the salinity of the seas in these regions, that is the mid-latitudes, is high. First of all, it is warm there, okay? There is no rainfall in these regions and no fresh water from the rivers. So that is why no fresh water is added in the seas. That is why the salinity is higher. Now, let's move on to the temperate zone now. That is above, okay? That is after the mid-latitudinal zones. Now, in the temperate zones or regions, the sun rays are slanting. You all can see in this picture, okay? So, therefore, the temperatures are lower, okay? It is lower than the mid-latitudinal regions. So, because of the melting of the ice, okay, because of the slanting sun rays, there is melting of the snow from that cold region. So the supply of water is also more, and therefore in this zone salinity decreases with increasing latitudes. Okay, so because there is continuous melting of snow, okay, ice and snow in these temperate zones, the fresh water keeps on adding to the sea. Okay, so that is why what happens, the salinity decreases in these regions. In the polar regions, okay, the temperatures are very low. Okay, you all know, right? So that is the Arctic and the Antarctic regions. Evaporation is also very less, okay, because the temperatures are low. That is why evaporation is less in the polar areas. So that is why what happens, children, the salinity also becomes low. Landlocked seas, okay, as we talked about earlier, have higher salinity than open seas, as the rate of evaporation is more and there is lack of supply of fresh water from large rivers. Thus, there is a difference in the salinities of open and enclosed seas. So, what happens, as I told you earlier, landlocked seas do not get fresh water from outside because they are blocked by land in all the four sides. So, that is why there is continuous evaporation but no fresh water is added to it. So, because of this, what happens? The salinity of this landlocked sea increases, okay, it is higher, and even the temperature is higher than the open seas. For example, the average salinity of the Mediterranean Sea is 39 part per thousand, okay, the Mediterranean Sea, while the salinity of the most saline ocean, that is the Atlantic Ocean, is 35 part per thousand. Now children, you can see the map of India, right? So in India, we have some neighboring water bodies like the Arabian Sea and the Bay of Bengal. Now children, if you can see here, the Arabian Sea, the salinity in the Arabian Sea is around 35,000, that is part per thousand. Okay, whereas in Bay of Bengal, it is around 34 part per thousand. Now children, do you know what is the reason, okay, behind higher salinity in the western coastal region? So children, it is because there is more water supply, fresh water that comes, and that is why there is no fresh water that is added towards the western side, whereas in the eastern side there is more of fresh water that is added. So that is why the salinity in the Arabian Sea is higher, okay, than the Bay of Bengal. Now children, have you heard about Dead Sea? The name of the sea itself gives an idea of the condition there. Okay, Dead Sea. That means nothing is alive in that sea. The sea, lying on the border of Israel and Jordan, has a salinity of 332 part per thousand. You can imagine how much salinity or salt is present in the Dead Sea. Now, the average salinity of the ocean, okay, the average salinity of the oceans in the world is around 35 part per thousand. Jordan is the only large river meeting this sea. Low rainfall, low supply of fresh water, and high evaporation are the major reasons of high salinity. There is no life here except few unicellular organisms. Because of high salinity, no organism can be alive in this water. The fish coming, okay, whatever fishes that come from the Jordan River into this Dead Sea, they die as soon as they come into the Dead Sea. So because of high salinity, there are saline pillars, okay, that are developed, okay, because there is continuous salts that are being created there. So there are pillars that are created. That much of salt is there in that water. Some of them come out on the surface, if you can see in the picture. Okay, these are the pillars. The density of water is also high because of higher salinity. Therefore, one can never drown in the sea. We can easily float when we go in the sea water. You can see a man who is floating in the Dead Sea, and this is because of the high content of salt in the water, which makes the density or the mass of the water even more, which allows you to float without much of swimming. Now, another characteristic of Dead Sea is that the land here is below the mean sea level. Okay, the sea level that is there, that is in the world, it is below it. So it is one of the places having the lowest elevations on the earth. It is the most lowest elevations of the world. In some areas, the altitude, okay, the height is minus 400 meters. So children, here we have the graph which is showing the temperature in degrees, then salinity per thousand and density of seawater. And towards your left and right, you can see the depth of the ocean or the sea in meters. So children, temperature and salinity, that is the content of salt in the water, are the two properties of seawater that controls the density of the seawater. If temperature reduces, density of water increases. So cold water is denser and so is saline water. As compared to salinity, temperatures affects density more. Hence, sometimes more saline water has lower temperature at the surface. But still, the density of such water is more than other water. Sea water having higher temperature and low salinity can have lower density. So children, in this graph, you know that the density of the water is dependent on two factors, that is the temperature and salinity. So if you see this graph very carefully, you will realize that after a certain depth, There is no change in these factors according to the depth. The change can be seen up to a depth of around 500 meters. So children, if you are looking at this graph, you can see that after 500, okay, the change is not there. Only till 500 you can see there is some curves, like in 0 degree, that is the surface of the ocean or the sea, you can see the temperature is around 20-21. Even the salinity is differing. So these all things, okay, that is temperature, salinity and density is differing, okay, varying up to 500. After that you can see it is constant. The slopes of the curves of graph are varying for all the three factors, okay. Everywhere you can see it is different. Here it is different. Even in salinity you can see it is varying, and even in the density part. So after the depth of 1000, okay, when you see after this, that is 1000, after 1000 you can see the constant, okay, the line is straight, it is not curvy at all. That means after the depth of 1000, from here for every factor you can see that there is no change at all. The pink line that you can see is in a straight line. Generally we call the sea water up to the depth of 500 meter as the surface water. That means the sea water up to 500, okay, up to this much of depth, it is called as the surface water. This water is affected by certain factors like ocean currents and sun rays. That means up to 500, okay, up till this depth, the effect or the effect of sun rays and the ocean currents can be felt in this depth. We can see the movement of these waters in the form of ocean currents, okay. So you might have learnt, okay, you have learnt in 8th standard about ocean currents, that is the warm ocean currents and the cold ocean currents. At greater depths, winds, sun rays and the currents do not affect any of these properties, because as you can see after the depth of 1000 everything is constant. Therefore after around 1000 meter depth there is no change in all the three factors. The ocean currents are generated because of difference in the properties of seawater, that is temperature, salinity and density. So they act as temperature controllers, okay, they control the temperature of the entire globe. The distribution of temperature gets controlled due to the ocean currents. Thus the climate of the earth gets affected by ocean currents. So that is why ocean currents is the main role behind the climate pattern of the globe. Now children, in your textbook there are a few questions that are asked depending on this graph. So we will have to look at this graph, study the graph and answer those questions. The first question is, with increasing depth, what decreases? Temperature, salinity or density? So the question means that as you go down into the sea, okay, this is the depth. So as you go down from 0 to 500 and 1000, what decreases? Does the temperature decrease, salinity decreases or density? So according to the graph, looking at the graph, you can see that temperature has decreased, okay. You can see that when it was in the surface it was around 21. Then when it came to 500, it started becoming around 16 degree. Okay, then slowly as it is coming down, as we are going down into the sea, it is decreasing. Okay, now at 1000 it is around 5 degree Celsius. So you can see temperature has decreased, and even the salinity is decreasing. So here we have the high and here we have the low. So near the surface, okay, the salinity is high, that is around 35.5, okay, part per thousand. Then as you go down into the depth, okay, it is decreasing, it is coming down. Okay, so that is why as the depth is increasing, what is decreasing? The temperature and salinity is decreasing. Next question, after what depth does the change in these factors become almost zero? So children, as during the explanation I told you that after, okay, that is after 1000 depth, okay, after the 1000 meter, there is no change. Okay, it is in a straight line. You can see there is no change in the temperature, nor even salinity, and not even in the density. So all these three factors are not changing after the meter or depth of 1000 meters. Next question, till what depth is the change in these factors higher? So the higher change can be seen up to a depth of 500 meter. So whatever changes you can see in all these three factors, it's only above 500. Okay, it's above. It is in the beginning it is more. Okay, then it's getting lower and lower. So you can see the curves above 500. Below 500 you can see it's getting lesser and it's becoming constant in all the three factors. Next question, explain the correlation between all the three factors. So if the temperature is less, then the density is more. If the salinity is less, then the density is also less. However, temperature affects the density more, okay, as compared to salinity. If the temperature is less, then the density is more despite less salinity. Okay children, here we have completed with the explanation for properties of seawater. Thank you for listening. Take care.